Okay. I am sharing my screen right now. So if you are not able to see it, then you can inform me. But I will try my best. It is visible to all. Is it visible?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Now the presentation is visible to you.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now we are going to discuss about the new topic that is called rearrangement. Rearrangement, the name itself says arrangement, but again arrangement, rearrangement. Okay. Some arrangements are already there. Suppose I am talking about ABC, that is standard arrangement, but it converted into BCA, that is called rearrangement. So in the term or based on this statement, we can say that the position of A is changed. Initially, A was with B. A, B, C means A was with B, but when it convert, that is called BCA. Now A is attached with C. So that is called rearrangement. So we are going to discuss this simple thing, logical things, but in the form of chemistry with the support of reaction. When we are talking about the chemistry, when we are saying that it's with the support of chemistry, it is little bit difficult. But if you understand the basic concept related to rearrangement, then it is easy for you to understand what I am going to discuss with you. I think the second slide is on screen. Rearrangement reaction. As per the statement or as per the definition, rearrangement reactions are an interesting class of reaction where a group or an atom migrate during the course of reaction. Means in presence of certain reagents or chemicals or catalysts, one group will migrate from one position to another position. This is called rearrangement. Based on this example or based on this figure, you can see here W is attached with A. But by certain chemical changes or in presence of certain catalyst or by reagents, it will migrate from position A to position B. So here now A W is attached with the position B. So this is called rearrangement. Rearrangement reaction involves the migration of a group or an atom from one center to another center. Now one center means the group which is attached with the center, that center is known as migration origin. And the group which is attached after migration, that center is known as migration terminus. So B is migration terminus, means group will migrate from A to B, or we can say group will detach from A and attach with B. This is simple or logical thing. But when we are talking about chemistry, what are the changes will take place? When you are talking about the chemistry, different types of migration may take place. There are three types of migration which I am going to discuss with you here. One, that is called first migration, that is known as nucleophilic migration. Now in nucleophilic migration, what happened? This group W will migrate from A with electron. આ group અહીંયાથી electron સાથે migrate થશે, means it can be converted into W minus and attached with the B. So this type of migration is known as nucleophilic migration or anisotropic. Anisotropic means negative. Anion means negative. Anisotropic migration. Migrating group migrates with its electron pair. Means W will migrate with electron pair from position A to to position B. This is one condition. Next one is known as electrophilic or cationitropic. Cation means positive charge. Electrophile means positive charge. Means W will migrate from this position to B without its electron. Means it giving electron, W is giving electron to A, and without electron W will migrate. So this type of migration is known as electrophilic migration. Migrating group migrates without its electron pair. Okay. And last one, that is called free radical migration. Now in free radical migration, what happened? Due to the homolytic fission, W will keep its own electron, A will keep its own electron. So what we will get? We will get free radical, and the free radical will migrate from position A to position B. So three types of migrations we will study. But in most of the cases or major cases, or as per the syllabus, we will focus on nucleophilic migration. These two are also there, but we will observe or see in selected rearrangement reactions only. But in major case, we will discuss about the nucleophilic migration. So as I said, if you are having information, if you are having clarity with the reactive intermediates, then you can understand very easily this topic. Now, next one, when it migrate, some changes will take place. As I said, in the beginning, I have simply shown you that W is migrating from A to B. But now how it migrate means this C plus carbon you have to consider as a B, and this carbon where R is attached you should consider as a and R equal to suppose W. So now you are having WAB. Now WAB means why, first of all, why group will migrate. If neighboring carbon having deficiency, or neighboring atom if having deficiency, then group will migrate from electron sufficient carbon to the electron deficient carbon, and it can convert it into another intermediate. So when this group will migrate, you will get another intermediate. Now this intermediate, based on the stability, based on the based on the reagents, based on the other chemicals, based on the chemicals, it will convert it into final product. But this intermediate is formed, and here it is known as rearrangement. Again, I am repeating, group R is attached with carbon. Okay, it migrating from this carbon to this carbon, means from electron sufficient carbon to electron deficient carbon. Why it is called electron deficient? Because it having positive charge, and we will get the product. In another case, here you can see carbon having lone pair of electron. So this lone pair of electron means this carbon may be in the form of carbene. If hydrogen is there, then it is called carbanion. So based on the condition, based on the reaction condition, here I am considering this is a carbene. Carbene means as per the octet rule, this is electron deficient. When it is electron deficient, group will migrate from electron sufficient carbon to the electron deficient carbon, and as a result, the valency of this carbon become high, or number of electrons are increases. So at the same time, this carbon become electron deficient, and that's why electron will migrate from this carbon to here, and as a result, we will get C double bond C. But migration of R from carbonyl group to the carbene, and as a result we will get this product. In the next case, we are having C double bond C. Again you can see carbon having two pair of electron. One pair of electron means two electrons are there. So this is known as carbene, and as per the octet rule it is electron deficient. That's why group will migrate from electron sufficient carbon to the electron deficient carbon, and then after electron will migrate over here and we will get triple bond. These are the three criteria where I can say, or we can say, group will migrate from electron sufficient carbon to the electron deficient carbon. Now these are things are little bit different what we have discussed. Why they are different? Because here two steps taken place simultaneously. Two step means leaving of group and migration of the group both takes place simultaneously. So in this case also we can call it's a migration or rearrangement. How? Here group Y will migrate from B and B become electropositive. When B become electropositive, at the same time X will migrate with electron from A to B and we will get this product. But sometimes if X is halogen, X is nitrogen, X is oxygen, in that case halogen, nitrogen and oxygen are having lone pair of electron. So instead of migration of the whole group, first of all, lone pair of electron will migrate on this position and as a result we will get the cyclic structure. But here also the leaving group means the group, detachment of the group and migration of the group both takes place simultaneously. We will discuss all types of reaction in our syllabus. So if you are having any doubt, any query, you can raise your hand. I will answer your queries.
So can we call this arrangement as a structure isomer?
Yes, we can
So
consider as a structural isomer because in this condition you can see there is a no change, okay, in the molecular formula. There is a no change in the number of atoms, only the position of the group is changing. So structural formula is different and that's why we can call it a structural isomers. Rightly you have said. I think you have uh, well studied the stereochemistry. Okay. Yes. Any other student having query? If you don't have any query, then now I am asking question to Bhumik. Please unmute yourself. On my panel, Bhumik is there. Unmute કર્યું?
Yes, sir.
Okay. તમને સ્લાઇડ દેખાય છે? આમાં ફોર્થ રિએક્શન એક્સપ્લેન કરો છો. Fourth reaction. આપને સ્લાઇડ વિઝિબલ છે ને?
हाँ सर.
Fourth reaction explain કરો. Who is there? Another students can answer this question. Anybody can answer.
Why
That's why I
molecules are hello sir.
have. Yes, please.
Why molecules is remove with two electrons. That's why the B molecules are comes positive charge. On that time,
Okay,
X
fine.
molecules is electron sufficient. That's why they migrate from A to B.
Right, right. So as per the reaction, this Y will migrate with his electron, leaving this position means position B with electron, and that's why A become positive. And when A become positive, the X will migrate with electron, and that's why the migration will take place from A to B, and we will get the product. Now, if you are sure or having clarity about the what type of migrations are there, or what should be the nature of the reactive intermediate, and then after the character of or nature of the migrating group, then it is very easy to understand about the various types of name rearrangement. We will discuss many name rearrangement. I think in our syllabus, 7 name rearrangements are there. So we will discuss one by one. But if you are having clarity or idea about what type of intermediates will form and then how the product will form, then I don't think I have to discuss much. Okay. So if you don't have any query or question, then I am moving on the next slide. If you have, then you can ask. Otherwise, I am moving to the next slide. So as per the syllabus, what we will discuss. In the syllabus, first of all, we will discuss about the general mechanistic consideration, means mechanism of particular name rearrangement. Then nature of migration. I have already explained this part based on nucleophilic, electrophilic, and free radical migration. So this part I have already explained, but in the topic it comes several times. So I will explain whenever it comes. Then migratory aptitude. Migratory aptitude is the most important criteria during the migration. Migratory aptitude means what? Here, as we have discussed about the nucleophilic migration. In the nucleophilic migration means the group will migrate from electron sufficient carbon to the electron deficient carbon. In that case, the migrating group should have sufficient number of electron and it should have tendency to donate electron. Then only that group will migrate, and it is known as migratory aptitude. Example, suppose if you are having alkyl group, simple methyl group, then if you are having a phenyl group, and if you are having substituted phenyl group. So out of these 3 groups, which group will migrate? That will be decided by electron releasing capacity of particular group. And this characteristic is known as migratory aptitude. It is known as migratory aptitude. And the last point, that is called memory effects with respect to the following rearrangement. Memory effects means which type of intermediate will form and then how the migration will take place and what kind of product will be formed. Each and every point we will discuss step by step. As per the syllabus, we will first start with the carbon-carbon migration. In the carbon-carbon migration, the groups are R means alkyl, H hydrogen, and Ar means aromatic. In the aromatic, substituted and non-substituted. When I am talking about substituted, it means some groups are electron withdrawing, some groups are electron donating groups. In that case, which group will migrate, that can be decided by the characteristic of the group already present. So if you are having R, H, and AR, wait. If you are having this type of groups, then which group will migrate? R, H, or AR? That is decided by the group. Means suppose if you are having H and R, then H will migrate or R will migrate. If you are having alkyl and AR, then R will migrate or AR will migrate. Right now, I am not discussing or disclosing that point, but when it comes, I will explain by mechanism. So we are going to start with the first reaction, that is called Favorsky rearrangement. Then subsequent, we will move further. Now, Favorsky rearrangement is related with C2C migration. As I said, migration of the group from electron sufficient carbon to the electron deficient carbon. So from electron sufficient carbon to the electron deficient carbon, here electron deficient carbon means, I think you are having idea that which kind of migration may take place. That migration may be in the form of nucleophilic migration or in the form of free radical migration. Two kind of migration may be possible. If you are having free radical, then also the electron deficient carbon is there. If you are having carbocation, then also we can say the electron deficiency on particular carbon. And that's why the group will migrate with electron or with one electron. If with electrons means nucleophilic migration, and with one electron or with electron, then it is known as free radical migration. Now, Favorsky reaction. In this reaction, what principle says? The principle of Favorsky reaction is conversion of alpha haloketones. Okay, conversion of alpha haloketones to ester. That is known as Favorsky rearrangement. But in presence of what? In presence of alkoxide. Okay, so if you are having only alpha haloketone, then you cannot get ester. And if you want to carry out reaction, then what you require? You require base, and normally here the base is alkoxide. If you are using alkoxide, alkoxide means what? Suppose if you are having methanol by treatment with NaOH or by treatment with sodium metal, it will convert it into Ca3CO minus Na plus. Again, if you are having methanol, Ca3OH, that Ca3OH by treatment with sodium metal, it will convert it into Ca3O minus Na plus. That is called alkoxide. Now, if you are using alkoxide, then you will get ester. If you are using base, that is called OH minus, then you will get acid. If you are using amine, that is called NH2 minus, that is also known as nucleophile, then you will get amide. So based on your base, you will get different types of product. This statement or reaction is given by Favorsky. That's why it is known as Favorsky rearrangement. Now, the role of the reagent or catalyst. As here mentioned, alkoxide, RO minus. What is the role of alkoxide? RO minus is known as nucleophile. This nucleophile will attack on the hydrogen. Why it is on hydrogen? Because H will be eliminated as a H plus and it will convert it into ROH. First of all, we will get ROH. When it converted into ROH, this electron will migrate from hydrogen to carbon, and as a result, we will get carbanion. We are having now carbanion. So, generation of carbanion, this is our first step. How it possible? By deprotonation. How deprotonation is formed or take place? By attack of alkoxide. So alkoxide attack on alpha position hydrogen, and then after deprotonation is taken place, and as a result we are having carbanion. Now the main step of rearrangement. As we have discussed, in rearrangement, what should happen? This group will migrate from this position to this position. That is called rearrangement. It means electron sufficient carbon, free electron deficient carbon. Now, in the structures, you are not able to find out which one is the most electron deficient carbon, but you are having electron rich carbon. Please unmute whose mic is on. Kartik, unmute yourself. Based on this reaction or intermediate step, we are having? We are having electron rich carbon, information of electron rich carbon. But which carbon is electron deficient? In the next step, you can see which carbon is electron deficient. In the fourth reaction or fifth reaction, I have said that simultaneous reaction will take place. Detachment of the group and migration of the group both take place simultaneously, and we will get cyclic structure. So here Cl having higher electronegativity as compared to the carbon, and that's why Cl will be eliminated as a Cl minus. When it is eliminated as a Cl minus, this carbon become electron deficient. When this carbon is electron deficient, it means what happened? We will get cyclic structure. Okay, we will get cyclic structure here. So cyclopropanone derivative is formed. Now from this derivative, which product will be formed? That also involve or important of your reagent, that is called RO minus. Here RO minus is attacking on carbonyl carbon. Here R minus is attacking on carbonyl carbon. Wait. R minus O is attacking on carbonyl carbon. So what happened first? So carbonyl carbon will pull electron, and carbonyl carbon when pull electron, then what happened? Wait a minute. Here, if I'm able to write, then I will write and show you. Here, carbon and oxygen. Here you can see oxygen having higher electronegativity as compared to the carbon. So oxygen will pull electron. From where? Oxygen will pull electron from the carbon, and as a result, this oxygen will gain negative charge, and as a result, here attachment of this group, that is called RO minus on the carbon. Attachment of the group on RO minus. So what we will get? We will get this type of structures. C here O minus and O R, okay, and remaining attachment, that is called our CH and CH2. This is remain as it is. This type of intermediate first we will get, and after that what happened? Oxygen having 2 electrons, so oxygen again converted into C double bond O. When it converted into C double bond O, here you can find the valency of this. If it converted into double bond O, valency of this carbon become 5. When it valency of this carbon become 5, then immediately either breaking of this bond, and this is known as C1 C3 bond, or breaking of this bond, that is known as C1 C2 bond. Now due to the breaking of bond, we will get 2 intermediates. Here you can see we are having 2 intermediates, one intermediate and another intermediate. This intermediate is known as methylene carbanion, and this intermediate is known as benzyl carbanion. And as per the stability of carbanion, which one is the more stable? So in the beginning, I asked question, and you have answered that this one, that is called benzyl carbanion, is more stable as compared to the methylene carbanion, and that's why the final product will be based on this. Will be based on this means what? The final product will be in this form. Means based on this product, benzyl carbanion. What happened now? ROH. Now the question is, from where we are having ROH? So if you have observed the reaction properly, then in the first step, what happened? When ROA minus attack on the hydrogen, what we have generated, or what was the byproduct? ROH. That same ROH will involve and react with this carbanion, and from ROH, what we will get? RO minus and H plus. So as we know, carbanion which having deficiency of electron, so carbanion will bind with this, and we will get what? CH over here. From here, as I said, from alcohol we have RO minus again. So in the beginning, to initiate the reaction, we have initiated the reaction with what? RO minus. And after completion of the reaction, again we are getting RO minus. So it is known as base catalyzed reaction or base catalyzed rearrangement. Due to that rearrangement, what we are having now? We are having CH2CH2 C double bond O OR. And in the beginning, what we had? CO CH2CH2. Okay. And in the final product, this CH2 will be here. And this is called rearrangement. The final product, okay, you can see CH2 at this position, here CH2, so we can call it a rearrangement. So if you have now any question or doubt regarding the rearrangement steps we have I have discussed for the Favorsky reaction, you can raise your hand and you can ask your query. Check any question query. Okay, if you don't have any question or query, then I will ask a question to you. Charmi Patel, unmute yourself.
Yes, sir.
Can you explain this step? આ સ્ટેપ એક્સપ્લેન કરી શકશો જે તમારા સ્ક્રીન ઉપર આવ્યું છે?
RO minus take on carbonyl carbon and minus taking and carbonyl carbon will pull electrons. Carbonyl carbon.
Try your best in your own word. There is no issue, but you should understand the chemistry first.
Carbonyl carbon.
Okay. Any other student voluntarily want to explain this step?
Sir, can I try?
Okay, sure.
RO માઇનસ જે એડ થાય છે ત્યારે કાર્બોલિન જે ડબલ બોન્ડ માંથી જે પાઈ બોન્ડ છે એ બ્રેક થઈને ઓક્સિજન ઉપર નેગેટિવ ચાર્જ આવે પછી ત્યાર પછી નીચે તમે સર લખ્યું છે એ પ્રમાણે જોડાય છે પછી જે માઇનસ ચાર્જ છે એ C ડબલ બોન્ડ ફરીથી કાર્બોલિન કાર્બન બનાવે છે ત્યારે C1 અને C2 અથવા C1 અને C3 કાર્બન બ્રેક થાય છે બે રીતે બ્રેક થઈ શકે છે.
And what we will get?
એક બેન્ઝાઇલ કાર્બોનિલ આયન બને છે અને નીચેનું બીજું એક સ્ટ્રક્ચર બને છે. બે સ્ટ્રક્ચર બને છે. C1 C2 કાર્બન બ્રેક થાય તો બેન્ઝાઇલ કાર્બોનિલ આયન બને છે અને C1 C3 બ્રેક થાય ત્યારે આ નીચેનું
Benzyl carbanion, carb anion. Okay, negative charge here, so we have to call it a carbanion, or you can say here methylene carbanion. Okay, fine. So I think whatever I have explained, you are getting that. So I should continue with the topics. Still, if you have any query, you can ask me. Otherwise, I am continue with the another reaction. ફરી પૂછું છું, કોઈને ક્વેરી છે કે હું આગળ જાઉં? ક્વેરી હોય તો પૂછી લો. Because when I am moving I will move further, the reaction or schemes or structures will be more difficult. તમે પહેલા જોયો છે મેં સિમ્પલ A B W થી સમજાવ્યું, પછી 5 રિએક્શન થી સમજાવ્યું, હવે ટિપિકલ એક્ઝામ્પલ થી સમજાવ્યું. Now I am going to discuss the structure that is little bit rigid or complex mechanism I am going to discuss with you. So if you are having any doubt or question, query, then please ask me. And if you are not asking, that I understand or I believe that whatever I am explaining to you, that you are getting, and with this concern I am moving further. Okay, so here we are going to discuss about the another type of reaction, but this is the cyclic structure. Previously we have discussed that is the open chain structure or open structure. Okay, no cyclic ring is there, but here the cyclic ring is there. Whenever the cyclic ring is present, the steps of reactions are, or principle of the reaction is same, but you have to simplify the structure. You can say this part is R1, okay, and this part is R2. If you consider this in this manner, then it becomes simple, like R1 CH2, okay, CCl H C double bond O R2. So whatever we have discussed, same thing over here, but the structure is cyclic, so the chemistry may be or steps may be little bit different, but I think you are having now idea about the structure. Or you can write one more part over here. Instead of this bond, you can write here, so you will get more clarity about this. So I will write it again here and here. So what we are having, R1 CH2 CCl H CH2 C double bond O R2. Here this part is known as R2 and this part is known as R1. So now you are having idea. It is as simple as whatever we have discussed, or we can correlate. But here the cyclic structure is there. That's why I have mentioned this for the simplicity or to understand. Okay. Now how the reaction is take place. So in the last step or last mechanism, what we have discussed, RO minus will react with hydrogen and it will convert it into ROH, and then after ROH further react. So as I said, carbonyl carbon, its neighbor hydrogen, that this hydrogen is known as acidic hydrogen. અહીંયા આપણે શું લખ્યું છે, CH2 લખ્યું છે. અરે બરાબર, સોરી, એટલે એક જગ્યાએ ભૂલ છે, આમ થશે sorry, R1 CH2 CHCl C double bond O CH2 R2 આવું થશે, એક મિસ્ટેક હતું, that I have rectified. So this hydrogen CH2, instead of CH2 I can write that is CH and H. In the first step is attack of RO minus. When RO minus is attacking on the compound, then H will be eliminated as a H plus, so we can call it a deprotonation. The first step is deprotonation. Here it is mentioned. Deprotonation is possible by alkoxide, and as a result what we are getting carbon ion. So ultimately it is the step is known as generation of carbon ion. This is known as generation of carbon ion. How we have generated carbon ion? By attack of RO minus, by attack of nucleophile, where on the hydrogen it will eliminated as a H plus, so we are having now carbon ion. Now this carbon ion, what happened? This is act as a nucleophile, strong nucleophile, because it having negative charge, lone pair of electron. So it will attack on the neighboring, or sorry, it will attack on the carbon where halogen is attached, because halogen having tendency to pull electron. So when halogen will pull electron, this carbon become positive, and as a result, a new bond formation will take place. So as I said, carbon having negative charge, it will attack on this carbon. Reason, this carbon is attached with the halogen, and halogen will pull electron. So these carbon become electron deficient. When this carbon become electron deficient, this carbon, that is called nucleophile carbon, will attack on this. Nucleophile carbon will attack on this, and as a result, we will get cyclic propanone type of structure, which we have discussed in last reaction also. Now in the cyclic propanone structure, as we are familiar with the reaction condition is basic, that is called RO minus. RO minus is there in the reaction, so RO minus will attack on carbonyl carbon. When it attack on carbonyl carbon, this one atom, that is called oxygen, will pull electron from the carbon. Due to the mesomeric effect, oxygen become negative. Here you can see oxygen having negative charge, and RO is attached over here. When RO is attached over here, again oxygen will convert it into C double bond O. When it's converted into C double bond O, either this or this structure is symmetrical, so out of these two, any one can will break, and the same intermediate will form. So here we will get CH minus. Here you can see CH minus. Why? By breaking of bond, an electron will be on carbon. So now we are having CH minus. This is known as again nucleophile. Now this CH minus will react with another compound, that is called ROH. Now from where ROH available, as we have discussed in the first step. So from ROH, it will convert into RO minus and H plus. Now this H plus will bind with this carbon, and we will get CH2. As a result, now we are having C double bond O, OR. So we can say we have converted alpha haloketone into ester. But in this reaction, we have initiated the reaction with a 6-member carbon containing compound. Okay, sorry, 6-member ring, 6-member cyclic ring. But at the end of the reaction, what we are having? We are having 5-member ring. So this is called ring contraction. This is called ring contraction. Means initially how the ring was 6-membered carbon ring, but after completion of the reaction, we are having 5-member ring. So it is known as ring contraction reaction also. એટલે ring 6-membered હોય તો 5-member થાય, 7-member હોય તો 6-member થાય. Due to what? Due to this type of steps જે આપણે બધા discuss કર્યા છે. Okay. Now if you have any query in this, then you can raise your hand, you can ask. છે કોઈને query? Dharmesh Damor, unmute yourself. છે ધર્મેશ દામોર? નથી. Harsh Boy.
Yes, sir.
Can you explain or mechanism? I will change slides for you.
Okay, sir.
From very beginning. ચલો બોલો. સ્ટાર્ટ કરો. This is our first slide.
ઓકે સર. ઓકે સર, અહીંયા જે આરઓ માઇનસ છે, જે આપણે આલ્કોહોલમાંથી પ્રાપ્ત થાય છે, જે ROH છે. ઓકે સર. એમાં જે સર આપણે જે ફર્સ્ટ ટાઈમ આમાં સર જે આરો છે તે H સાથે જોડાઈને ROH જે ROH ફોર્મ કરે છે, જેને લીધે જે CH2 હતો, જે આલ્ફા હતો, જેનો જે કાર્બન આયનમાં રૂપાંતરણ થાય છે. અને જે COO ની જે રાઈટ સાઈડ જે છે C, એમાં જે Cl હતો તે દૂર થાય છે.
હા, પ્લીઝ કન્ટિન્યુ.
હા, અને જેમાંથી જે પેલો જે CH જે કાર્બન આયન છે, તે જે આ જે ઓકે જે Cl દૂર થયો તે ઇલેક્ટ્રોન લઈને દૂર થયો. તેથી જે COO ની જે રાઈટ સાઈડ કાર્બન છે તે ઇલેક્ટ્રોન ડેફિશિયન્સી ધરાવે છે, મીન્સ પ્લસ ચાર્જ ધરાવે છે. તો જે CH માઇનસ છે એઝ અ કાર્બન આયન, તે CH પ્લસ જોડે જોડાઈને સાયક્લિક સ્ટ્રક્ચર બનાવે છે, એઝ અ સાયક્લોપ્રોપેનોન ડેરિવેટિવ. ઓકે, અહીંયા જે આરો માઇનસ છે તે એઝ અ ન્યુક્લિયોફાઇલ છે, જે અટેક કરે છે સી ડબલ બોન્ડ ઓ ઉપર. અને જે સી ડબલ બોન્ડ ઓ નો જે ઇલેક્ટ્રોન છે, તે જે ઓક્સિજન છે તે વધારે ઇલેક્ટ્રોન નેગેટિવિટી ધરાવે છે. તે ઇલેક્ટ્રોન પોતાની તરફ આકર્ષે છે, તેથી તે O માઇનસમાં રૂપાંતરણ પામે છે. અને ત્યારે જે આરો માઇનસ છે ત્યાં જે સી સાથે જોડાય છે. ઓકે, અને જ્યારે તો સી સાથે જોડાય છે ત્યારે જે સીની જે વેકેન્સી છે, મતલબ જે પાંચ સાથે જોડાવાની જે ક્ષમતા ધરાવે છે તે વધી જાય છે, જેથી જે સી બોન્ડ ઓ હતો, જેની પર O માઇનસ હતો, તે ફરીથી સી સાથે ડબલ બોન્ડ બનાવે છે. અને જ્યારે તે બનાવે છે ત્યારે જે 1,3 ઓર 1,3 બોન્ડ ઓર જે 1,2 બોન્ડ છે, એ બંને સાથે બ્રેક થઈ શકે છે. અને જે બેન્ઝાઇલ કાર્બન આયન ઓર મિથિલિન કાર્બન આયન જેની સ્ટેબિલિટી વધારે છે, તે રીતે બ્રેક થાય છે.
ઓકે, થેન્ક યુ. બીજા કોઈને આઈ થિંક આપણે પ્રોપરલી જેટલા સ્ટેપ્સ મેં એક્સપ્લેન કર્યા છે, બધા સ્ટેપ્સ એક્સપ્લેન કર્યા છે. જો કોઈને છતાં કોઈ ક્વેરી હોય તો ડિસ્કસ કરી શકાય. If you don't have any query, then I will move further. In the beginning, as I said, instead of alkoxide, if we take a base, then we will get acid. Okay, if we take amine as a catalyst or reagent, then we will get amide. So different types of products we can form or prepare with the support of this reaction that is called Favorsky reaction. But in the Favorsky reaction, the most important thing is alpha haloketone. When I'm talking about alpha haloketone, in the alpha haloketone, the common thing is the carbonyl compound or carbonyl group must have hydrogen in its alpha position. If this position is not there or this hydrogen is not there, then the first step may not occur as per the Favorsky. Okay, we have discussed two reactions. In the two reactions, the first step of the reaction is attack of alkoxide on the proton. So what we can say, alpha hydrogen should be present. Alpha hydrogen if there, then we can carry out the reaction by route of Favorsky, and it is known as Favorsky reaction or Favorsky rearrangement. But this reaction is modified by Cauchy, and then if it is known as Cauchy-Favorsky reaction. I will directly moving on that part first because time is about to complete. So I am not going to discuss its reaction, but just to highlight on the topic. Here in the Cauchy-Favorsky reaction, here you can see absence of alpha hydrogen. પેલા બધામાં શું હતું? CH2 હતું. અહીંયા આગળ phenyl છે. Here the hydrogen is absent. Here also the hydrogen is absent. But in special condition, in a strong nucleophilic condition, the reaction is take place for some compound, and this is given by Cauchy. So it is known as Cauchy-Favorsky rearrangement. So next time we will discuss in detail about the Favorsky reaction and some other rearrangements also. As you know, the most of the teachers are about to complete their task, but I have taken more time for the discussion of reactive intermediates. So still my near about the 45 to 50% syllabus is left. So I will arrange some extra classes for you. I will send you link whenever I able to arrange the extra classes, but please join the extra class and attend it properly. So as per the schedule, as per the time permits, we will complete our syllabus. But still, if you are having any question, any query, you can raise your hand. Otherwise, we can end the meeting. If you have any question, query, then you can ask. Otherwise, I'm going to end.